Hey everyone, this is a video showing how we use data version control implemented right now with a local git-LFS enabled GitLab instance. We will be using a microbiome example, but this workflow should be applicable to other types of data analysis. First, let's shell into Chiha. I'm on a Windows computer, so I will be using the OpenSSH client that comes with Cygwin. And as you can see, I'm already shelled into Chiha. So let's first change directory to Scratch and take a peek at what's there. So what we have is a directory called demo input files, which is just where I've staged our demo data, and a M141 directory, which is an empty Git repo that we created earlier by forking a microbiome template using the DVC libtools. That process was shown in a separate video, and I'll link that in the description. So let's change directory to M141, and let's copy over the demo data files. So for a real data analysis, you can imagine that we're copying over the raw sequence files from wherever we have staged it, so we can begin to put things under version control. You can see that we have a forward and reverse directory. These happen to be paired end data. You can do a DU and see that the total sizes are about 1.5 to 2 gigabytes. And you can also do a quick count, and about 72 files per directory. So the point being, this is fairly representative of a typical microbiome data analysis. So let's clear the screen. Okay, so first I like to check that git-LFS is in my path and that I'm using the recommended version. So I'm just going to type git-LFS version. We experienced some issues with 2.3.0 with early adopters, which 2.3.4 addresses, so that's the version I want to use. Next, before I add these input files to Git, because I know they are large and I want them to go into LFS, I'm going to double check the tracking rules. So you can do that by typing in git-LFS track. And as you can see, the way the tracking rules are set up right now, anything that goes into the forward or reverse directories will go into LFS. So what I'm going to do is I'm going to git add both of these directories to put them into the Git index. Then it's good practice to double check that Git has put the files you expect into the index before you actually commit. So you can do git status, and you can kind of eyeball that. That looks good to me. And because everything so far actually should go into LFS, let's look at the git-LFS status. And there are these sections to the git-LFS status output, and we're just checking that the git-LFS objects to be committed, the list looks as expected. So everything actually looks about right to me, so I'm going to issue the git commit next, and I'm just going to write a simple log message that we are adding the input files. Okay, again, let's check our work. So I'm going to type in git status, and it tells me that we are one commit ahead of origin on master, which is what we expect. I'm going to take a quick peek at the log. Looks good. And because I just committed files that go into LFS, I'll usually also double check the output of git-LFS ls files. And again, I'm just scanning to see, and that looks good, so I am satisfied. And let's clear the screen real quick. Next, we are going to run the quality control step of the pipeline. So let's load our QRAP data analysis environment. Right now we do that by sourcing the env file, which is in our shared production scripts directory, so we can just source share apps NGS. There's a QRAP production support scripts directory, and there's actually a QRAP env file. You should see your prompt change. That indicates that the expected environmental variables have been loaded, including the QIIME1 conda environment. While we're here, we're going to make directory analysis. This is just part of the standard microbiome analysis directory layout. The QC job script is actually called xmerge workflow2, so we're going to copy that as well out of the production support scripts directory. All right, and then we're just going to modify it for what we need. I'm just going to change the email address. And just scanning this script very quickly, it looks like it needs to run from the parent directory. So we're going to do that. Okay, so now let's submit this job to the Slurm scheduler. So we're going to run sbatch, and then the argument to the xmerge workflow2 script is just the main analysis directory. So the job is submitted. This will run the QC steps described in the xmerge script and then email us when it finishes. So for now, let's just clear the screen and wait for that email. Okay, so the QC step has completed. So let's change directory into M141. Let's do a quick git status. So as expected, we need to add the new analysis directory to version control. And let's take a look here. According to DU, we've got 11 gigabytes worth of output now. Let's take a quick peek at the results. Yep. All right, so let me remind myself about the Git tracking rules, the LFS tracking rules. Okay, so as you can see, the fastqc directories are going to go into LFS. And another reminder, let's take a look at the ignore file. And we're actually going to send some part of it, we're just going to ignore it. And so we've determined that the FASTA files, for example, are not necessary to save for reproducible research, so we're going to leave those out. So let's run git add and add the analysis directory and its contents, again, according to the LFS rules and the git ignores, to our index before we commit. Also, let's not forget, for reproducible research sake, we not only want to save the QC results, but also the captures of standard output from the Slurm job and the exact job script itself. So let's go ahead and move those before we forget. So there's the Slurm output, and then there's the job script. We're going to want to move that into analysis. Right now, the convention is to place these files in the analysis directory for the microbiome group. So let's get back into the M141 directory. Let's get back into analysis. So now let's git add those two files, so the Slurm output and the xmerge script file. And let's run git status. And again, as always, before you commit, we're double checking the index via git status, git-LFS status. We can also see that the things we expect to be ignored are actually being ignored. And so you can see the FASTA files that are in the git-ignore file are being ignored. And we can actually run git-LFS status. This can take a few minutes to run, so I'm just going to look at the last 100 lines. But, and again, we're checking to see that what's supposed to go into LFS actually goes in there. Okay, so for a real data analysis, I will spend time here, especially if I'm starting from a template with LFS rules and git ignores that I didn't write myself. And the point is to closely scrutinize the output to make sure I'm fully satisfied before I commit. So in the interest of keeping things flowing in this video, however, I'm going to move on. So we are going to commit the QC output. Okay, so the commit finished. So let's run git status. And let's see. As expected, we are now 2 commits ahead of origin master. And if we check ls files or LFS ls files, then we should have all of our QC output in the LFS listing. Okay, so let's scroll up past all the forward and reverse stuff. That's from our input files commit. And it looks like the fast QC directories are in fact in LFS. So this looks good to me. So let's clear the screen and move on to the next step. So at this point in a real QRAP analysis, I would be planning to run the microbiome workflow 1 via the cluster job script and the advanced analysis after that, and then generate the standard report. And between each of those steps, I would inspect the output, git add, status, log, LFS status, commit, LFS, ls files, as you have seen me do for the input files and the QC step in this video. So all of that is going to work the same way. So for now, I will skip to showing you how git push works. So once you are satisfied with the commits to your private data analysis Git repo, and you are ready to publish those commits to the central repo, that's what we created in the last video, then you will run git push. Before I run git push, I will check git-LFS status closely one last time. So let's type git-LFS status. And in particular, the git-LFS objects to be pushed to origin master section is what I'm going to be paying special attention to. These are the objects that will go to the LFS store. Anything not on this list will go to the Git repo. Don't worry about all the missing stuff. That's actually a known string formatting bug that should be fixed in the next git-LFS client release. Okay, so now I'm ready to run git push. So let's type git push origin master. And this command is going to send the LFS objects to the LFS store and the rest of the files to the central repo. Okay, so git push has completed. So now let's switch back to Chrome and let's scroll down, click on the M141 project and scroll down, and we can see the input files and the analysis directory containing our QC output. If you click on forward, then you can see the input files from the forward strand. They're tagged LFS. Let's go back to M141, and you can click on the analysis directory, and you can scroll down and see the QC output. You can see the slurm output and the xmerge job script, and you can click on those, kind of take a peek at the contents of these. So exactly what we expected, right? So everything that we did on Chiha is now reflected in the central repo that we're browsing through the GitLab repo browser. And you can scroll over here and look at your commits, and you can see your log messages. So anyways, you can browse around and check things out, but this hopefully gives you a taste for how we are trying to use GitLab plus git-LFS for data version control. So this is a work in progress, and there is plenty left to do.